heat exchange equipment. Heat exchange equipment is broadly classified into two categories. One is heat exchangers, and the other category we will have condensers and evaporators. Condensers and evaporators. Heat exchanger is the term here. Heat transfer without a phase change. Without a phase change. Here, heat transfer with the phase change. With the phase change. So, heat transfer without phase change means heat transfer takes place between two fluids. Initially also, for example, between two liquids. Then initially also liquid state only. Finally also liquid state only. For example, here water at 30 degrees centigrade is to be heated to water at 70 degrees centigrade. This is the example. Okay, water at 30 degrees centigrade is to be heated to water at 70 degrees centigrade. So at 30 also water liquid form. Here at 70 also water in the liquid form only. That is, there is no phase change. So without the phase change, for this type of heating or cooling, so heat exchangers are used for heating or cooling of fluids. Heating or cooling of fluids. Used for heating or cooling of the fluids without a phase change. That is the heat exchanger. Now, condensers, evaporators. Condenser, here vapor will be condensed to liquid, and evaporators, liquid will convert to vapor. There is phase change here, from vapor phase to liquid phase, from liquid phase to vapor phase. This is heat transfer with the phase change. Condensers briefly we have discussed in last class. Evaporators in 5th unit we will discuss. Here now we will discuss heat exchanger. Now also in this unit we will discuss only the how heat flow takes place, calculations and energy balances, such things we will discuss here. In 4th unit we will discuss construction and working of different heat exchangers. Okay, so now heat exchangers here is again divided into two types. Here DPHE, that is double pipe heat exchanger, double pipe heat exchanger, and this is shell and tube heat exchanger. Shell and tube heat exchanger. Like these heat exchangers are again two categories. One is double pipe heat exchanger, the other is shell and tube heat exchanger. In shell and tube heat exchangers, you will have again a single pass 1-1, single pass 1-1 heat exchanger, 1-2 heat exchanger, and 2-4 heat exchanger, etc. Like this is the classification of heat exchange equipment. These also heat exchange equipment. Heat exchangers are also heat exchange equipment, but we use the term heat exchanger for the special case where initially and finally same phase, that is no without phase change, when heat transfer takes place, for that type of heat transfer we use heat exchangers. will discuss what is double pipe heat exchanger and how heat transfer takes place. So in the double pipe heat exchanger means we will have two concentric pipes. Two concentric pipes. One inside the other. Concentric means here with the same center. With same center. So here like this. This is inner tube and this is outer tube. This is inner tube and this is a outer tube. Like this we will have inner pipe and this is a outer pipe. This is also outer pipe. That means center is same here. This is inner radius and this is of the inner pipe and this is inner radius of the outer pipe. And this is actually what? This is annular space. Annular space between inner and outer pipes. Annular space between, that is when we introduce one pipe inside into another, then surrounding the inner pipe you will find space, that is the annular space. So here one fluid will be flowing here, maybe say hot fluid here and another fluid will be flowing here, this one, this is a cold fluid, like this. Okay, so through the annular space one fluid, let it be hot or cold. In some cases we send hot fluid through the annular space, depends. So one fluid inside the inner pipe and the other fluid outside the inner pipe means through the annular space. And here this is what, since here hot fluid is flowing, no, this is wall of the inner pipe. Then what happens? Heat transfer takes place from inside of the inner pipe to the outside of the outer pipe, like this. So through this wall, heat transfer by conduction. Heat transfer by conduction. And similarly here, heat transfer takes place from hot fluid to cold fluid, like this. So here heat transfer takes place by conduction. And after reaching this outer surface of the inner pipe, this is the inner pipe wall now, this is inner surface of the inner pipe, this is outer surface of the inner pipe, both inner pipe only, inner surface, outside surface. So from outer surface of inner pipe, within this fluid, heat transfer takes place by convection. Heat transfer takes place by convection. HT by convection. Okay? Like this, the double pipe heat exchanger. Slightly brief only here. Brief construction. Then how it works, that we are sending hot fluid and also cold fluid. And when how to send this hot fluid and cold fluid, then we will see how to utilize this double pipe heat exchanger. In how many ways we can bring contact between hot fluid and cold fluid. How heat transfer takes place between hot fluid and cold fluid, we are bringing hot fluid and cold fluid into contact. We are bringing hot fluid and cold fluid into contact. Is it but physically separated but thermally in contact? This is the point. Hot fluid and cold fluid are physically separated. But thermally in contact. Okay? Physically separated by which layer here? Which wall? Inner pipe wall. Physically separated by inner pipe wall. Okay? These two fluids are physically separated by inner pipe wall. So now hot fluid loses heat and cold fluid gains heat. Heat transfer takes place through this inner pipe wall. Now, how to bring these two fluids into contact? How to bring these two fluids into contact with each other? The two fluids, hot and cold fluids, can be brought into contact in two ways. In DPHE, especially DPHE, hot and cold fluid can be brought into contact in two ways. Okay? What are these two ways? Number one, parallel flow. Parallel flow means this is also known as co-current. Number two, counter flow. Number two, counter flow. Okay? In double pipe heat exchanger, hot and cold fluids are brought into contact in two ways. One is parallel flow contact, the other is counter flow contact. Now we will discuss each contact, that is parallel flow and also counter flow separately. First we will see parallel flow. What is mean by parallel flow? For example, this is the entrance of the heat exchanger DPHE. Then one fluid enters here. Say here PCA, PCB. That means C indicates cold, A indicates entering. So PCA is the entering temperature. Of cold fluid. Okay? Then PCB indicates, C indicates cold, B indicates leaving. So leaving temperature of cold fluid. Okay? So now TCA, that means cold fluid is entering here and leaving here. Now hot fluid. See this. This is THA and this is a THB. What do you understand from this? Cold, this is what THA is what? THA is entering, A indicates entering temperature of hot fluid, and THB is leaving temperature of hot fluid, that is TH and THB. After seeing this schematic diagram here with the help of arrow marks, what do you understand? Both hot fluid and cold fluid are entering at the same end and leaving at the same end. Is it clear? So this is called parallel flow contact. That is, what do you say now? Parallel flow means in parallel flow contact, in parallel flow contact, what happens? Both cold and hot fluids enter at the same end of the exchanger. This is the parallel flow contact. Hot fluid, where hot fluid, which end hot fluid is entering, cold fluid is also entering at the same end. Both enter at the same here, and flow in the same direction. And flow in same direction. Okay, and flow in same is the same direction. Arrow mark indicates direction of flow. So same side arrow mark. Both are flowing in the same direction. Now here, what is the difference between here is at the entrance always delta T1, at the exit always delta T2. Delta T1 is delta T at the entrance. Delta T1 equal to delta T at the entrance, and delta T2 equal to delta T at the exit. Okay. So now, what is this delta T1 in this parallel flow? We are discussing parallel flow. Okay. So delta T1 equal to what now? THA minus TCA. THA minus TCA. Delta T1 equal to THA minus TCA. And delta T2 is equal to THB minus TCB. Delta T2 is equal to THB minus TCB. Okay? In counter it will be different. We will see afterwards that. So like this, delta T1 and delta 2 we need to write. Just in the simple diagram, just by drawing two lines you can write what is delta T1 and delta T2. In last class I explained what are delta T1 and delta T2 are called. Delta T1 and delta T2 are called what? Approaches. Do you remember? Are called approaches. Okay? This notation remains the same throughout your subject. THA, TCA, TCB, THB, those things remains same. Now this same diagram, we will draw the graph like this and discuss. Here, this is temperature. This is a temperature y-axis. This is distance from cold fluid inlet. Cold fluid inlet. Okay? Means cold fluid inlet means what? Is it TCA? Entering temperature of cold fluid is TCA. This is cold fluid inlet. So in this direction, what is the distance? How distance is changing? When distance means nothing but what? Length of the pipe. So when length of the pipe is changing, how temperature will change. You know that it's very clear that in the double pipe heat exchanger, as the any heat exchanger, of course, as the length is increasing, then temperature will also change. Okay, how it will change, that also you can tell. Hot fluid loses heat, so hot fluid temperature will decrease and cold fluid temperature will increase. That's what happens along the length of the tube. Now, and one more point in this diagram, always draw first cold fluid line. Cold fluid temperatures are lower than hot fluid temperatures. Okay, that is why this upper line always for hot fluid, because THA, THB are higher than TCA and TCB. That is why first draw cold fluid line and then above hot fluid line. Now for parallel flow, we are going to draw this diagram. Now start with the cold fluid. Cold fluid temperature, as the distance from, means tube length, in other words, you can write in simple words, tube length, tube or pipe length here. As the tube length is increasing, what happens to cold fluid temperature? Cold fluid temperature will go on increase. So you start here with TCA. What is TCA? Entering temperature of cold fluid. Then as length is increasing, slowly here cold fluid temperature will rise, and this comes to TCB. Okay, so initially cold fluid temperature TCA, finally at the exit of the exchanger cold fluid temperature is TCB. Now because this is parallel flow, we are discussing for parallel flow, here cold fluid is entering, so hot fluid also enters at the same end. So let it be hot fluid temperature, say THA. Then what happens when tube length is increasing? THA will decrease. So here slowly THA will decrease. Okay, this is THB. Now this is a direction of cold fluid, and this is direction of hot fluid. What do you say about these two directions? Direction of cold fluid and the direction of hot fluid, both are in the same direction. Okay, both are in the same direction. Both are entering at the same end and flowing in the same direction. This is what is called parallel flow contact. Like this is first way of bringing these two fluids into contact. Now here, what is delta T1? This is delta T1. This is delta T1 and this is delta T2. This is delta T2. Okay? This is delta T2. And what is delta T1? THA minus TCA. Delta T1 equal to THA minus TCA. Delta T2 equal to THB minus TCB. THB minus TCB. That means this much diagram we are represented by using simply just two lines. Same thing we are getting. That means when you working out problems, you need to draw this diagram in problems. Okay, this you need not show in problems. In problems, use this. So next what else? One more term I said. This is approaches. Then one more term I taught you last class. What is that term? Range. What is the term? Range. last class. When we go to shop, if I want to purchase sarees, the shopkeeper will ask me what is the range. I may say 5,000 to 10,000. That is minimum value, maximum value. That means it ranges between. In the same way, range is the minimum temperature and the maximum temperature. In condenser, you will have only one range because cold fluid temperature only changes from TCA to TCB. But hot fluid temperature remains constant. And in heat exchanger, you will have range both for hot fluid and also for cold fluid. Then can you tell me what is the range of hot fluid? Okay, what is the range of hot fluid is equal to range of hot fluid THA to THB, and range of cold fluid is equal to TCA to TCB. So you will have two range of hot fluid and range of cold fluid. This is a parallel flow contact. And LMTD, after discussing counter flow, then we will write at a time what is LMTD. Now second way is counter current contact. Second way of bringing contact between hot and cold fluids is counter current contact. For this, what is the two-line diagram here? First, draw for cold fluid as I explained you earlier. Name it as TCA and TCB. Always draw for cold fluid first. It is easy for you. TCA to TCB. Then, because it is counter flow, when cold fluid is entering here, hot fluid will enter the other direction. So, this is THA and this is THB. Okay, see, entering temperature this direction here and hot fluid. That means, how can you define now counter flow? Counter flow is defined as how? Both the fluids will enter at different ends of the heat exchangers. The two fluids, hot and cold, enter at different ends of the exchanger, and flow in opposite directions. This is what? Counter. This is a counter contact. This is the definition of counter contact. Two fluids, when cold fluid is entering this end of the exchanger and flowing like this, hot fluid enter the other end of the exchanger and flow in the opposite directions like this. So this is a counter flow exchanger. Now in this here, this is delta T1. Whether co-current or counter current, delta T1 is always at the entrance and delta T2 is always at the exit. So this is delta T2. Okay, both in parallel and counter, delta T1 is always at the entrance, delta T2 is always at the exit. So what is delta T1? What is delta T1 here? THB minus TCA, and delta T2 is equal equal to T delta T2 equal to THA minus TCB. Okay. Whereas in case of parallel flow, this is different. THA minus TCA delta T1, but here different. Just by drawing two lines, you can write very correctly. Now the same counter flow, we will also draw that diagram with respect to tube length. Here. Distance from cold fluid inlet. It is nothing but a tube length. And here temperature. Same diagram, same x-axis and y-axis what we have seen for the parallel flow. So here now cold fluid enters here, say TCA, this direction. Then slowly its temperature will, you should have a gradual increase. So this is a TCB, okay? This is the entrance of the heat exchanger, double pipe heat exchanger. TCA is entering here and leaving at the other end of the exchanger. So this is how it is flowing. This is direction of heat flow, direction of flow of cold fluid. Direction of flow of cold fluid. Direction of cold fluid, you can say, okay? This is direction of cold fluid. Next, we will draw the curve for hot fluid. When cold fluid is entering this entrance, at the entrance, then in counter flow, hot fluid enters at the other end. So this becomes THA then. Okay? Then gradually it decreases its temperature. This is THB. Now this is direction of hot fluid. This is direction of hot fluid. Okay? This is direction of cold fluid. This is direction of hot fluid. Now you understood that they are in the opposite directions. This arrow mark is this way and this arrow mark is this way. Now what is delta T1 for this? This is delta T1, okay, and this is delta T2. Okay, so what is delta T1? Delta T1 already we wrote, that only we will see. So what is delta T1? THB minus TCA, same thing here, THB minus TCA. What is delta T2? THA minus TCB, THA minus TCB. So this whole graph we are showing in simple manner of using two lines, which this is useful in drawing problems. Okay, so this is again range, same as range. These are approaches. Then range, same thing, just like this one for hot fluid and cold fluid. This is THA to THB and this is TCA to TCB. Same thing, just like parallel. Okay, now the very important discussion is which flow gives you, which contact gives you the maximum Q, which contact gives you maximum Q. parallel I just want to show you, because we want to compare both for the parallel and here. This is THA and this is THB. This is TCA and this is TCB. This is hot fluid and this is cold fluid. This is parallel and this is counter. Okay, now we will compare these two. When you can say that the heat exchanger is working efficiently. When heat exchanger is working efficiently, when can you say that? When outlet temperature of cold fluid comes near to the inlet temperature of hot fluid. Okay? Outlet TCB, outlet temperature of cold fluid should be near to THA, that is inlet temperature of hot fluid. Then we can say that Q is more, maximum. Q is maximum. So, in which case this is Q is maximum now? Here, if you say this one, this is THA. This is THA. Okay? This is TCB. So, this much difference is there. When you come to this is THA and this is TCB. This is the difference. So, compare it to these two, you can understand very easily that in case of counter flow, outlet temperature of cold fluid is coming near to the inlet temperature of the hot fluid. So, counter flow always gives you more heat. Higher value of Q is maximum in counter. Okay? Then you may question one thing. Then why to use co-current? Why to discuss all these things? We can always use counter only. That question will arise. The answer for that is sometimes we need to control the outlet temperatures of the hot and cold fluids. We want to limit the outlet temperatures. In such case, we can use a parallel flow. But counter flow, when you have choice, you can. When you want to have higher value of Q, we can select a counter flow. Thank you.